Mother eat cookie. Yum, 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 yum. Goodbye.
Right, I'm back. Looks like someone's been like cookie crumbs on this computer, but it looks like my lectures are. Let's go. Somebody's been on my computer, probably one of my kids. Anyway, that's fine. Everything's fine. Looks like maybe Brooke even set this up to record. So we're going to pick up where we left off and talk about ways of knowing. At least I hope we are. There we go. We're going to talk about ways of knowing. And I hope you recall from the last short lecture that aphorisms, folk wisdom illustrates that there are different ways of knowing or thinking that you know things. Another way to say that is that people often trust their intuitions when other ways of discovering the nature of the world would yield very different answers to an important question. As it turns out, I've argued this for about 2 decades now in my research methods book, and no one's corrected me yet, so I think this is right, that there are 4 ways that you can know things, and we're going to quickly review each of them in the rest of today's lecture on the 4 ways of knowing. Okay, the first way of knowing we just explored a little bit, that's intuition. It's a gut feeling, it's common sense, it's things like folk wisdom. And so if you trust a hunch when you're playing a game or a sport, or if you don't trust a person who's trying to help you at a store because they remind you of, you just have a bad feeling about them, maybe they remind you of your cousin who's not very trustworthy, those are examples of intuition. Okay, that's one way of knowing things. It works sometimes, but of course it's imperfect. Secondly, there's also authority. So intuition probably came first. So 10,000 years ago or 180,000 years ago, when there were barely people on planet Earth, we've only been here for 200,000 years, intuition was the main way to know stuff. Because we live in groups, though, and groups almost always have leaders, authority pretty quickly became a second way of knowing things. And once we invented writing and started living in cities and having constitutions and Hammurabi's code and things like that, authority took on a lot of importance, so that if you wanted to know the answer to a question, and the question was about how to make a good horseshoe, well, you talked to a blacksmith. If the question was about math, you talk to a person who did math, who was a mathematician. So authority has been around almost as long as intuition. And since human beings invented writing something like 7, 8, 9,000 years ago, authority has become a very big way to know things. Logic has been around almost since the beginning of writing, but really the formal rules of sophisticated reasoning have not been around quite as long as authority, because we didn't have logic when we didn't have writing. So until we had writing and math, and they developed at the same time, people invented writing as a system of accounting, keeping track of debts and transactions. And that eventually led to math, and it led to the past tense of verbs, and it led to the something like 7,000 languages that we have on planet Earth. So logic is a very formal, very highfalutin set of rules about the correct way to reason. If you ever take a course in philosophy, if you ever get your PhD in philosophy, you will take entire courses in different kinds of logic. And since I was a philosophy minor of sorts in college, I took a complete course in logic. I learned what the contrapositive was. I can't remember it exactly right now. But of course, logic and the highest form of logic is mathematics, is another good way to know things. That leaves us with the way that psychologists prefer the most, actually. And that fourth way of knowing things is observation. Look at something. I don't mean just take a casual look, record it with an instrument, measure it with a measuring tape or a stopwatch or a telescope, write it down, record it in an objective way that you hope other people can replicate, can repeat. That's observation. People often say they've made an observation when they made a casual observation, but they may have done so in a way that scientists would say would not qualify at all as an objective empirical observation. So using a telescope, especially if the telescope has built-in technology to make recordings for you, definitely observation. Looking at a person and saying she looks lazy or he looks happy, that's a much more casual observation. We do ask people to do that sometimes in the laboratory, but we're very careful about the way we record it, the way we interpret it, and so forth. If you've ever taken a public opinion poll, I used to work at Gallup and they do that for a living, that's a careful observation. You work really hard, for example, on the way you word your question to be sure it doesn't bias people in a pro-Republican, pro-Democratic direction, for example. So that is observation. And in this lecture, we're going to take a close look at each of those 4 different ways of knowing, how they're different. Each has its pros and cons. Obviously, as an empirical scientist, as a psychological scientist, I prefer observation. Logic is my second choice, by the way. Authority is my third, and intuition is my last. But I do use my intuitions as a researcher. If I didn't, I wouldn't get very far. Okay, so let's do some activities. I'll make these sort of hands-on if I can. It's not easy when we're in a remote setting, but I'll make these as hands-on as I can. I had to cut a few of these because I can't be in the room with you, but let's do a few activities that illustrate the 4 ways of knowing. This is certainly one of my favorites, if not my favorite demonstration of different ways of knowing. This is the checkerboard shadow illusion developed in the 1990s by Edward H. Adelson, who's a vision scientist and a cognitive scientist. And he's showing us here in this image that squares A and B, believe it or not, are exactly the same shade of gray. Now, if you've seen this before, you probably knew that. If you haven't seen it before, you may think I'm a little crazy, but I'm telling you empirically, if we pointed a photometer at square A and square B, it would tell us correctly that they are exactly the same shade of gray. People often don't believe me when I tell them that. I'm going to try to prove it to you as well as I can, but you'll still have to trust me a little. If you don't trust me about this at the end of this demonstration, print this out or look it up on the web, print it out on a piece of paper, cut those out with scissors and compare them, and you'll see that in fact A and B are exactly the same shade of gray. Let's debias that here by covering up pieces of the image, and I hope you can see now that I've covered up the image. In fact, I'll even cover up the A and the B. You can see, let's see how well I can point here. Yeah, you can see that this rectangle is exactly the same shade of gray. I hope you can see that as this rectangle. And as we move forward here and uncover the image piece by piece by piece, you will see, of course, that the illusion reappears in a pretty powerful way. So even when Edward H. Adelson looks at this image, A looks a lot darker to him than B does, even though he's the person who created the illusion. So knowing that there's a visual illusion at work does nothing to change your intuitions about it, to change your gut feeling that one thing is bigger, one thing is faster, one thing is crooked, one thing is straight. In this case, one thing is dark gray and one thing is light gray. So that's an example of your intuitions and the fact that a careful observation can show that your intuitions are not correct at all. Okay, so that's that. This may be my very favorite visual illusion. This was developed, I think it was Roger Shepard, a cognitive psychologist named Shepard. Sometimes I get him mixed up with the astronaut Alan Shepard, but I'm pretty sure this was Roger Shepard. He came up with this great illusion a couple of decades ago now, and his point is the lines that you see here on these tables, these edges, so line A and line B, are exactly the same length. And by the same token, Y, which I've highlighted here in blue, and Z, also in blue, those are the same length. Okay, so those tabletops are exactly the same shape. Not sort of, but exactly. So again, if you print this out on a piece of paper and you cut out the tabletop on the right, you could lay it on top of the tabletop on the left and it would look exactly as it does. Now, that's not how it feels to us. That's not what your intuition tells you. In fact, here's a great question about your intuitions. If you trust me for now, and I'll prove it to you in a minute, I hope, if you trust me for now that lines Y and Z are the same, and that lines A and B are the same, is it also the case, though, maybe one of the ways that he cheated, this is actually an updated version of the tabletop illusion. Roger Shepard's wasn't exactly like this. The clever person who made this version put the Apple book on. The Apple book, I think, makes the illusion even stronger. So here's a question. Okay, if Y is the same as Z and A is the same as B, are those Apple books really the same? Maybe they made the table look wider on the right by making that Apple book long and skinny, and they made the one on the left look longer. One of the things they did by making that Apple book look wider, long and skinny in the other direction. So right now, my question for you is, are those Apple books also identical? If you cut one of them out on a piece of paper, would it overlap perfectly with the one on the other table? Take a minute to answer that question. Are the Apple books really identical, even if we agree that the tabletops are identical? Okay, try to come up with an answer. Make your best guess. 5, 4, 3, 2, 1. The answer? I'm thinking some of you said, no, the books are obviously different, even though the books are also absolutely identical. You see those two books very differently, just like you see the two tabletops very differently, because your eyes have learned and your brain has learned through, let's say, a couple of dozen or 20 years or only 19 years of looking around in the world, that if you're in a real room with two tables, and you saw something that looked like this, it would in fact be the case that the table on the left is longer and skinnier, and the table on the right is shorter and fatter, closer to square. And so your eyes are automatically making an adjustment that they learned to make through, let's say, about 20 years of being of engaging in vision, of figuring out that things look different at different angles from different perspectives, and you automatically make those corrections. I can debias this for you. I can make the illusion disappear by just making the tables disappear. I'll leave up the lines for you. We have A, B, Y, and Z exactly as they were, I promise. And now I hope you can see pretty clearly that A and B are about the same length, and Y and Z are about, in fact, they're exactly the same length. When I made this image, I copied and moved line Y to make it line Z, and I copied and moved line A to make it line B. But I can make the illusion come back with just the vaguest suggestion of a table by just adding some vague lines here, some faint purplish lines, adding what looks like some legs. And as soon as I do that, I hope you'll agree that the two parallelograms, we'll call that one on the left AY, and we'll call the one on the right BZ, they now have begun to look different again. So again, knowing about the illusion doesn't make the illusion disappear. Intuition often, we're missing a leg there. Intuition often flies in the face of careful observation. Okay, activity 3, how good is your peripheral vision? This is really hard to do remotely, but I took a little picture last night, that's what I put here, of what I want you to do with your right hand. I want you to reach into a pocket or purse and grab a coin, shake it up in your hand the way I'm doing it right here without looking at it. And you're going to grab that coin, you're going to put it, let me try to get in the camera, in one of your hands in your right hand. You're going to take your thumb and hold it up like you're hitchhiking, put that in your left hand. And just like this dude that we see here, you're going to stare. Let's see, you're going to close your left eye. I just did it. You're going to close your left eye, and I'm trying to show you this here on the screen, and stare at your thumbnail. Then you're going to take that coin that you haven't looked at. I'm going to show it again. I'm going to try to. That you've not looked at, and very gradually, now you're not doing this yet, you're just getting ready. Very gradually, you're going to stare with your right eye at your thumbnail, and you're going to do what this cartoon dude is doing. So very slowly, holding a coin in your right hand with either the head or the tail facing you. You don't know which one it is because you didn't peek, you were honest. You're going to gradually move your right arm towards your thumb. And the question I'm posing to you is, Exactly how far apart will your arms be? How far will that coin be from your thumbnail when you can clearly, not guessing, but clearly see which side of the coin is facing you? Now, I put here pick an answer between 0 and 52 inches. When I'd given this lecture, I don't know, 6, 8 years in the past, I put between 0 and 36 inches because I didn't think carefully about how far that is. But last night, I measured the distance from my thumbnail to my arm if I make that little triangle, and it was about 51 inches. I'm a little over 6 feet tall, so if you're 6'5", it might be 54 inches for you. If you're only 5 feet tall, it might only be 44 inches for you. But you start off with that coin about 50 inches, let's say, away from your thumbnail. You gradually move it to your thumbnail, staring at your thumbnail. And again, the question is, how far will the coin be from your thumb in inches? Pick any answer there before you can tell for sure if the head's side is facing you or if the tail's side is facing you. So do that. Before you do it, as a careful observation, though, of course, write down your guess. And once I've given you 5 seconds to write down your guess, I'll tell you what my guess was the first time I did this activity. Okay, gonna make a quick guess. 5, 4, 3, 2, 1. I hope you've written down a number. When I did this about, oh my goodness, 15 years ago now, because I was reading a book by Antonio Damasio, he gave this clever demonstration. I think I wrote down 2 feet, about 24 inches, because I had just been back from the eye doctor the day before, and I was told that I had very good peripheral vision. So I was, of course, proud of that. I'm proud of anything I happen to be good at. And so my guess was 24 inches. Okay, then I did the activity, and I'll give you a minute now to do the activity, and we'll see what the correct answer is. So take as long as you need to carefully do the activity. That was my phone, by the way, I silenced it. Do the activity. Left hand straight out in front of you, staring at that thumbnail without moving your eyes at all. You're moving that coin closer and closer and closer to your thumbnail. And if you do that, you will see that it's way, way less than 24 inches. Even if you have great vision, it's going to be, give me a few more seconds. Yeah, you've done it by now. It's going to be about an inch. For some people, it's less than an inch. For the occasional person, it's an inch and a quarter, maybe an inch and a half. The coin basically has to be right on top of your thumbnail before you can really read the fine details. And especially if you wanted to read the date on the coin, it would have to basically be touching your thumbnail. So what that tells us, I bet, is that your observation revealed something very different than your intuitions. And if we wanted to click here, let's see what a much younger version of me had to say about this. Well, probably a 5-year younger version. Let's see what I said about that.
The hands-on activity I'm asking you to do here involves taking a coin out of your pocket and putting it in your right hand, holding between your thumb and your finger, but being very, very careful not to look at it first.
That's redundant. You already heard that. But if we want to click on that one, it would just say what I just told you, which is that I bet your observation was very different than your guess. If you guessed that it would be an inch or so, that's an amazing guess. Okay. If it really is an inch or so, you should go into the Marvel Cinematic Universe and become Hawkeye or something, because no regular human eyeball or visual system works that way. We only see things well in crystal clarity and in full color if we're looking right at them. Now, our mind creates the illusion that we see everything around us in great detail and vivid color because our brain fills in what we saw yesterday or 3 seconds ago or a minute ago based on our knowledge of what's red and what's green and what's big and what's small and so forth. So you have an intuition that your visual system works, in a sense, much better than it really does. And I bet you can guess that that intuition can get you in trouble sometimes when you're driving and you think you can look at your phone screen and also get a good look at the road at the very same time. Guess what? You can't. Neither can I. Okay, that was activity 3. Speaking of looking at your phone and the road at the same time, I would like to do a demonstration with you on multitasking. Now, when I tried this yesterday, I had tremendous difficulty with it, but I think I changed the settings on my computer to make it work. If it doesn't work, I'm going to try not to get too frustrated or to break into tears or anything, but I'm hoping this, yay, it works. It works. Okay, I'm going to do for you a divided attention task. Now, you could do this on your own. You could go to that web address there, which I linked into this lecture, and you could probably Google Thinker divided attention task if you wanted to. And you could do this activity as well. I'm going to make this, I'm not going to make it any bigger because I may have technical difficulties if I do that. So what I'm about to do is to click this start button. And when I do, I will have to do 2 things at the very same time. I will have to take a spelling test over on the right of the screen. It's going to be about right here. And while I'm doing that pretty straightforward spelling test, moderately difficult, I would say, I'm going to have to watch a shape being drawn over on the left-hand side of the screen. So my job is keep track of the red moving dot and know what shape it's making, and try to do as well as I can on the spelling test as well. Now, I've done this a few times, so it's easier for me than it would be for you, because I keep repeating the same spelling words, by the way. But I'm going to do it anyway to give you a sense of what it's like, and I encourage you to do it yourself later on your own to learn something about divided attention. All right, here we go. I don't have my glasses on, but I'm going to try it without. I think I can see the screen well enough, even at my advanced stage, to read those words. We'll find out. Let's go. Okay, curious. Yes, that's spelled correctly. Litigate. Yes, my wife's an attorney. Abacus, I think that's right. Yeah. Tomato. No, that's wrong. No. Oh, dang it, I was too slow. I got 4 right and none wrong, but there are 6 questions in the test. I got a D. I got 4 out of 6. That's 66.67%. I barely passed the test. Here's the other bad news. I was focused so much on talking to you and taking the spelling test that I barely glanced over only a couple of times at the shape making dot, and I do not know what the shape was. I'm going to guess, I'm pretty sure it wasn't the star. I'm going to, instead of eating up a lot of your valuable time, I'm going to guess that it was the letter B, maybe a cross. I'm going to go with a cross. Let's see, go with a cross. I guessed a cross. I guessed it, but I promise you I got lucky. And when I've taken this test in the past, I've been at 1 for 5 or 1 for 6. I'm guessing because I barely glance over at the shape. And if I focus on the shape and I get that correct, guess what? I got a 1 or a 2. I got a low D or an F. I'm sorry, a low F on the spelling test. Even when 2 things are right on the screen right here, just a couple of inches apart, I can't do them well at the same time. And you can't either, because that's not the way the human brain works. But the human brain often tells us that we can do things like that when in fact we really can't. All right, so let's get out of here. Now this may take some doing. Let me see if I can get back into the lecture. Yay, it worked. Okay, so that's activity 4. Our intuitions about our ability to multitask fly in the face of what we can actually do. Okay, careful observation shows that our intuitions are wrong. Okay. Now, yeah, let's answer this question. I was ready to move on too quickly. What are the logical implications of this demonstration for the best way to study for a class? Should you ever study for any class, unless you've already mastered the class, and watch a movie at the same time? I hope it's obvious that the answer is no, you shouldn't. Would it be okay to listen to instrumental music while you read? If that blocks out extraneous noise, probably, but if the music has lyrics, even that's probably not a good idea. So anything you can do to focus your attention on just one thing when you study, whether you're studying for Gen Psych or advanced calculus, no matter what the topic is, if you don't know the topic yet, you're learning, you're thinking hard, And it's very hard to think hard about something new while you do anything else. So the logical implications of this are focus on just one thing when you'll notice, for example, that I'm not texting my friend here while I'm talking to you because I want to focus completely on this lecture and give you my full undivided attention. Okay. Activity 5, that went a little quickly. Sorry, it zipped ahead on me. This is a brain teaser that I remember well because my older brother, Stacy, gave it to me when I was like 35 or something. And I have a reputation for being the geek and the genius in my family, even though 2 of my siblings are smarter than I am. But I'm the one with a PhD, so they think I'm smart. Stacy gave me this brain teaser, and I'm embarrassed to say I just failed miserably. I don't know why, it just stumped me. Now, once I took a long time to think it through, I logically worked my way to the right answer, but there's something for me at least about this little brain teaser that just made it really hard. Okay, what is it? Here it is. I'm making it clearer for you than Stacy did for me, by the way. I'm doing you a little bit of a favor, but here we go. Jamal said, brothers and sisters have I none, but this man's father is my father's son. Now, from Jamal's perspective, you got to know who you're talking about here. From Jamal's perspective, he's the person who gave the quotation. From Jamal's perspective, who is this man? Brothers and sisters have I none, but this man's father is my father's son. Yeah, from Jamal's perspective, who is this man? Okay. Some of you have gotten it. You just got it. Like, oh, I see. Yeah, my father's son. Yeah, okay. So here's the way to get it in case you haven't. And if you've gotten it, you know. My father's son is me. I'm my father's son. If I didn't have any siblings, I'd be my father's only son. So my father's son, we can logically substitute me. That makes it much easier. Brothers and sisters have I none, but this man's father is me. I am this man's father. Oh, it's Jamal's son. So from Jamal's perspective, the answer is his son. But I promise you, if you give this little brain teaser to most people, they will find it, most of them at least, maddeningly difficult, even though logically we can work our way to the correct conclusion. So that simple, logical answer often eludes people. It often gets away from people. And it certainly got away from me the first time I heard it. Okay. All right. There we go. That's activity 5. Activity 6 is sort of a syllogism. This is mostly for fun, but I'm illustrating something philosophers call the fallacy of equivocation. And I do remember that from my course I took in college many, many years ago. Equivocation is a particular kind of logical error. Look it up if you're curious, equivocation. And this is kind of entertaining because the person probably knowingly commits the fallacy of equivocation. Here we go. God is love. Love is blind. Derek Paravicini, the amazing pianist, by the way, you'll hear more about Derek later in this course. Derek Paravicini is blind, completely blind. And the conclusion, of course, Derek Paravicini is God. That's not a lot. Now, if you've seen Derek Paravicini play the piano, he plays the piano like God, but he is not literally God. And again, the mistake here is equivocation. It's meant to be mildly entertaining. Hope Derek would be entertained if we selected him, because I could have selected any person who's visually impaired. But that's an example of the fact that logic can be a little bit tricky. Now, in this case, because you know that Derek Paravicini is not God, you find it entertaining. But in other cases, people make the same mistake. They make it all the time in political dialogue. Once I give you my twisted definition of racism, you can't accuse me of being racist anymore. So people often make this mistake in debates and arguments. And what it means is logic is tricky. Now, philosophers can often identify logical fallacies in our thinking, but lay people and even trained scientists aren't as good as philosophers at making those identifications. So that just shows us that logic is pretty difficult, or at least it can be. Here's another example of the fact that logic is really difficult. In fact, this is called a logical paradox because for centuries now, for thousands of years, philosophers have been having heated debates about exactly why you can never get to Rome or Athens or wherever you're going. In fact, you can never get anywhere, but let's pick Honolulu. You can never get to Honolulu, okay? Yes, I can. I've been there. No, you can't. Here's why you can't get to Honolulu. It's because of Zeno's paradox. So Zeno was this ancient, I'm pretty sure, Greek philosopher who came up with lots of paradoxes. Many of them are a spin on this same paradox, by the way. So Zeno, once he had a good idea, he beat it to death, but fine. His best known paradox, known as Zeno's paradox, is this. If you want to get to Honolulu, there's you, there's Honolulu. It's a long way, by the way. If you want to get there, of course, the first thing you have to do, we can all logically agree, is you have to get halfway there. You can't get to Honolulu if you never get halfway to Honolulu. So the first thing you must do, everyone agrees, to get to Honolulu is you got to get halfway to Honolulu. Okay, step one, get halfway to Honolulu. Step two, get halfway to the remaining half of the way to Honolulu. I don't know if I drew that perfectly, but I hope you can see I'm representing that it's half of the remaining half. That's step two. Now, I didn't put step three here on the screen because it wouldn't fit well, but obviously step three would be get halfway to the remaining half, which is halfway to that final quarter of the way to Honolulu. Then there's an eighth, then there's a 16th, and I hope it's becoming pretty clear to you, even if you've never heard of Zeno or his paradox, that it is kind of a paradox. So here's the question. Well, there are two of them. First of all, on what numbered step does this logical process end? When do we finally get there? The answer, oh yeah, you're right. The answer is never, because there's always step three, step four, step 1,000, step 48,392. And that's a paradox, of course, because it means we all know that you can get to Kansas City or Honolulu or Athens or Thebes. We know you can get to the bathroom. But according to Zeno's paradox, you can never get any of those places because first you have to get halfway, then a quarter, then an eighth, then a 16th, then a 32nd, then a 64th, then one 128th, then one 256, one 512, one divided by 1,024. It goes on forever. And according to Zeno, logically, you never get there. Now, Zeno knew that you get there. He gets to the bathroom. He got to the grocery. But we can't get places logically according to this particular logical way of thinking. According to common sense, intuition, and even careful observation, we can get places. So I give you this paradox to illustrate the idea that different ways of knowing sometimes butt heads, and it's not always clear which logical way is the best, and it's not always clear that logic trumps intuition. We all know that we get places. Zeno knew that we get places, but through one logical analysis, we never can. Okay, those are different ways of knowing butting heads with each other. All right, a couple more of these. Sometimes I end up picking a lot on intuition, so I like to make fun of stereotypes because I study stereotypes and they're often wrong. They're not always wrong, but they're often wrong. And so I often make fun of intuitive thinking or stereotypes or your gut impulses, but intuition does have its advantages. I'd like to illustrate that for you here by showing you these three images. If you think that these are like the horoscope sign Pisces, some constellation turned sideways, it does kind of look like a fish, but most people who see these three images have no idea what they are. If you know what they are, good for you, but most people have no idea. But in a second or two, I can not only show you exactly what they are, I can show you that your intuition knows more than you knew you knew. So first of all, what are these? Let me click on this little animation. You'll see quickly what this is. Oh, wow, that's a wait. Let's see that again. That's a person. I had no idea until I saw it move. Yes, that's a walking person. Not only that, that's a walking gender neutral person. That's an exact mathematical average of the way the average man walks and the way the average woman walks. If you see these next to, you will know in an instant, as my daughter did 5 years ago when I think she was only 6, that one of these is male and one of them is female. You knew, without knowing you knew it, you knew intuitively that men and women on average walk very differently. Now, this is a very macho male walk and a pretty feminine female walk, but here we go. You tell me which one this is, the man or the woman?
Yeah, it's a man, you can tell, can't you?
Hear my daughter in the background saying it's a boy. I was recording that. She looked over my shoulder at the age of 6 and said, it's a boy. She knew. And so once I had pulled her into the circle, I said, well, what about this one? You'll be able to hear her very well here.
All right, Brooke, what do you think now? Is it a boy or a girl?
A girl.
Good job.
Good job, you stereotype. So you can see I don't always consciously teach my kids the stereotype, but notice I didn't have to. She had learned intuitively by the age of 6 that boys and girls, men and women, walk differently. And that shows you that our intuitions are constantly absorbing facts or what we perceive as facts, even when we don't know that it's happening. So intuition is not always wrong, and it's certainly not all wrong. That's intuition. Okay. I did suggest in that last example that intuition can be superior to things like logic or even careful observation. Okay, so I said that. I'm going to give you a couple of more demonstrations here of the power of intuition. And you're going to use your intuitions here if you don't mind. Again, I'm going to try to make this at least a little bit hands-on. Use your intuitions to tell me which of these surnames is the most common surname in the 2010 US population. So that's a decade ago now, but the 2020 data aren't in yet. Using data from the 2010 census, I carefully looked up the frequency, the popularity of different surnames in America. And I've got a pretty diverse range of them. And I bet in almost every case, I think I have at least 8 of them, you'll be able to tell me just using your intuitions without Googling it, without consulting with a census officer. I think you'll be able to tell me just using your guts, using your intuitions, which of them is more common. Now, I had a little trouble with this yesterday. There we go. We got nine pairs of them. We have a bunch of different pairs of surnames. Now, I'm not going to ask you to rank them all because that would be crazy. Let's just start with Kramer versus Wood. Those are European American. Those are white names, Kramer and Wood. And I bet you have a very good sense of which of them is more common. So we're going to go through it quickly. Which is more common, Kramer or Wood? And I'll give you your answers. Yes, you're correct. It's Wood. What about the Latinx surnames Murillo versus Garcia? Murillo versus Garcia. I'm just giving you a second. This should be like that. It shouldn't be a difficult thing. Yes, you're correct. It's Garcia. But wait. What about Ramirez versus Espinosa? Yeah, you got that one too. It's Ramirez. Yeah. In fact, even if you don't know a lot of people who are Latinos, if you watch a lot of baseball, you will get that one right. Okay, so those are 3 intuitions. What about another European American name, another white name? I bet even if you haven't lived in America that long, you know that Smith is a very common name, and you may have never even heard the name Shea, but Smith is much more common than Shea. Almost 1% of all Americans are named Smith. Okay, here's an Asian American name. This could actually be Korean or Chinese or some other nationality, but I bet you know pretty quickly that, is it Ho or is it Kim? Yes, Kim is much more common than the name Ho. And even if you don't know anybody from Vietnam, I bet you can guess that one of these Vietnamese names is more common. And it is, of course, you knew it, didn't you? Yeah, it's Nguyen. Nguyen is more common than Pham. I know a couple people named Pham. I know a bunch of people named Nguyen because I used to work at UCLA, which has a very large Asian American population. Chattopadhyay, and I'm sorry if I'm not saying it properly, but I actually have a colleague I've worked with named Amitabh Chattopadhyay, and he always has to help me with his name. But he has to help me in part because I'm an American who doesn't know my Indian names that well. But I bet you know your Indian names well enough to know that the name, one of those is more common. Yeah, the name Patel is much more common than the name Chattopadhyay. This one I get mixed up on because I've studied these names myself when I do work on racism and stereotyping, and people do miss this one sometimes. But I double checked it last night, and the name Washington is quite a bit more common than the name Jefferson. Those are the two empirically most African American US names. So if your last name is Jefferson or Washington, there's a very good chance that your ethnicity is Black or African American. But there are white people named Jefferson and white people named Washington. White or Black, there are quite a bit more people named Washington than there are people named Jefferson. Finally, a quick German name. I had an instructor in grad school whose name was Dwayne Albrecht. I think he was a German immigrant, but I also could have told you way back then that the other name, Schmidt, is a much more common German name than the name Albrecht. Notice we just raced through 9 names. I could have sped it up if I'd wanted to, and you saw that I bet in most cases, maybe even in every single case, you could tell me just using your intuitions which of those names was more common. So intuitions can be pretty darn useful. Okay, our intuitions give us quick answers to questions that might be very hard to answer if we had to look them up or do the calculations. People's intuitions are usually pretty accurate. I'm going to share with you something we will often do. I don't know if we'll always be able to do it, but we'll often do this in this class. We will often get an answer of some sort to the important question, how's the weather out there? So with a little help from my daughter just yesterday, I asked a few people, I basically ripped this off from John Krasinski, how's the weather out there? And let's see what we found. I hope this will work.
And thank you, Candace, for that very depressing report on climate change. On a much happier note, we're going to go throughout the United States today to our roving reporters and get an answer to the important question, how is the weather out there?
Dang, it is hard out here.
Hope you're finding this at least mildly entertaining.
Well, thanks for asking, Brett. I just checked all my indicators, and I do have very exact indicators here of the weather. And it is exactly 103.5 degrees outside, and our humidity is at a low 17.3%. There you have it from Arizona.
Let me go ask my mom. I'll be right back. She said it was like low 80s or something. I don't know.
Hi ho, Kermit the Frog here, your roving weather reporter. And I am in a relatively rural part of Rockville, Maryland, a wooded area. I do not have any measurement instruments with me, but I will tell you that I know for sure that the weather just 8 miles north of here is 89 degrees Fahrenheit, and the weather just 14 miles south of here is 91 degrees Fahrenheit. Not being very good at math, I'm going to estimate the temperature here then to be about 90 degrees Fahrenheit.
All right, so that was Kermit's report. You saw reports from 4 different people, and I thank my friends and colleagues who helped me with that little activity. But we're going to do how's the weather out there as often as possible. I won't promise that we can do it in every lecture, but we're going to do it to illustrate different psychological principles. But for right now,
and thank you, Candace, for that very depressing report.
Right now, we're going to move on. And I hope you become familiar enough already with the fact that I forgot to capitalize authority. I hope you become familiar with these concepts enough that you can very quickly tell me in this matching activity which primary, now sometimes people use more than one way of knowing, but if you had to categorize these 4 ways of knowing, these ways of expressing what the weather's like out there, which way did each person use? So I'll give you a minute to do this. It's our last activity today. We're coming up on 50 minutes. I don't like to go that long, but tell me which way Barry was using, which way David was using, and so forth. See how quickly you can do that. All right, Barry, I'm gonna do it with you if you don't mind. And I'll give you another minute. Let's see, Barry. Oh yeah, Barry. I know which one he used. He used intuition. It feels hot to me, right? Yeah, he just trusted his intuitions. Now, David, by the way, is the co-author of the modules I've borrowed as part of your PDF for this Z course. So David is the co-author of my intro psych textbook. He just joined me not that long ago, and the book's going to come out soon, as I told you. David, of course, is an empiricist. David trusts observation, and he trusted observation there. And I'm pretty sure what he told you was factual. He lives in Phoenix, Arizona, and it is hot there. Okay. Brooke, my daughter, who's my technical consultant for this course, by the way, she said, I don't know, I don't have a thermometer. I'm going to check with a person I consider an authority. In her case, it's her mom. And notice she didn't check with her dog because the dog's not an authority. And through sheer logic alone, we can see that Kermit, as I talk about Kermit, I feel my voice morphing in his voice a little. Kermit was using logic. Now, he also had some observations at his fingertips, but he averaged, he used simple math to say if it's 91 a little bit south of here and it's 89 a little bit north of here, it's got to be about 90 degrees. That's logic. So that is your final example for the day of the 4 ways of knowing. Great talking to you, and I hope to talk to you again tomorrow when we talk about research methods. Take care. Be safe.